Hi, and welcome back to our discussion of environmental policy and law. This section is going to talk about pollution control, something that really didn't take off in the U.S. until the mid-20th century. And we'll talk a little bit about water, air, and waste, the kinds of pollution that we were dealing with. We'll talk a little bit about the Environmental Protection Agency, which runs the Superfund, or at least oversees the Superfund, and is now really in charge of overseeing and maintaining water, air, and waste pollution issues. And then we'll talk a little bit about international policy and what's going on there. With regard to water, the original effect here or intent was to clean up water systems. So the pollution of rivers and streams, especially in the eastern U.S., had gotten so bad that Midwestern cities in the area of like Cleveland, like Ohio, or even like New Jersey, the water was filthy because raw sewage and waste was ending up in these places. And Chicago had the same problem and actually was fouling up Lake Michigan, and so eventually reversed the direction of the river in an attempt to send that stuff down to Mississippi. The idea behind the Refuse Act of 1899 was basically said is that in any navigable waterway, you're not allowed to dump raw sewage or chemicals straight into this. The idea that we're going to clean up all of the other bodies of water that are adjacent to these navigable bodies because you're not going to be allowed to dump water upstream. Say if we have a basement or a catchment area like this, you shouldn't be able to dump it into this system because eventually it's going to flow down into this system, so it's basically the same as dumping it straight in here. And that didn't really happen, partly because it's very difficult to regulate this in 1899, although I think it did help for some of the most extreme cases. We see changes in federal pollution. Not until 50 years later do we see federal regulations, Water Quality Improvement Act of 1970, and then finally in 77 we see the Clean Water Drinking Act, or the Clean Water Act, which requires essentially secondary processing of sewage. Now we've talked about sewage processing. The first step of this is settling, right? So this is coarse material settling out of the system. So that basically means that the secondary mechanisms of processing, which might be things like biofiltration, I mentioned aeration, right, promoting the breakdown of organic material, or even oxidation to break that material down. None of that was happening or was required before 1977. Now the Clean Water Act funding has lapsed for this since the mid-90s, and it has not been picked up again. Although I will tell you that it does not mean that certain cities are going to or have stopped doing secondary processing on raw sewage. I should also point out it does not mean that raw sewage does not end up in Lake Michigan as well. During periods of heavy rainfall, when systems are being essentially overtaxed, Lake Michigan is going to get sewage from Green Bay, Milwaukee, and from Chicago, even with the deep tunnel system that Chicago has installed. With regard to air, we see Clean Air Act come around in the 1960s, amended in the 90s, okay? In relationship to chlorofluorocarbons. These are the things that are eating the ozone hole. And, increased regulation by 1965. One of the main things with Clean Air Act was that we were seeing areas of intense acid rain. And so, in the 60s, we didn't know anything about CFCs affecting the ozone. We didn't even have satellite imagery that was telling us much about the ozone's influence, although we had things like polystyrene probably since the 1950s, aerosol cans as well. But what these air quality acts did was they helped to establish acid rain or reduce acid rain by the output of SO2 into the atmosphere, or SOx and NOx, and it helped to establish a cap and trade, basically limiting emission plants to 1 ton per year, okay, free, and then the rest of their emissions, so this is a coal fire plant down here, have to be capped. And emitting plants can I'm going to say buy the right to put more SOx and NOx into the atmosphere by trading with other plants that are maybe less polluting or not used as much. And so we do have a cap and trade on sulfur dioxide in this country, and it is run by the EPA in an annual auction. And you could buy credits. You could buy SO2 credits if you wanted to, but it's not an international market, and it's not an open market by any means. Okay. Solid Waste Disposal Act. We didn't really have much of a solid waste disposal policy, right? We had a lot of open landfills prior to 1965, and we didn't have sanitary landfills. And we talked a little bit about landfills and landfill leachate. Here's an example of a landfill that's open on this side, capped on the right side, and you can see water and evaporation, so percolation or precipitation and evaporation, moving in and creating that leachate that we talked about having to be extracted from the subsurface at the base of the landfill. So prior to these acts, we saw that municipal waste was just deposited in big holes in the ground, the city dump, with no real sense in how these things were constructed. RCRA, which is the 1976 act, we start to see plans for the disposal not only of landfill waste that's strictly speaking and not supposed to be hazardous, although leachate itself is pretty hazardous. Okay, but we also see for the disposal of hazardous wastes, and by 1984 we see small waste generators generating less than 1,000 pounds per month, also having to dispose of this hazardous material or toxic material in a satisfactory way, which may be depositing it in a more extensive type of landfill, like not a sanitary landfill, but a secure landfill. The other thing that we see in the 80s with regard to landfills was regulation of underground storage tanks. Okay, this thing is what's under, or some version of this is under your every service station out there, and these things were made of metal. They were made of metal with a single wall, and by 1980 we figured that many of them had been leaking into the ground, and so throughout the 90s, I would say, there was a lot of work for entry-level geologists in what we call the Yanka tank, where you go out to a place, they dig it up this tank, you test the soil, remove any of the soil that's been contaminated, and then potentially backfill it or replace it with a double-wall tank. That would be a requirement, or a tank that would not corrode and rust through. Now, by 1970, we still don't have anything that we have federal laws, but we don't have good, solid footing on who's going to enforce these laws. And it was the EPA that was developed with the idea that it would enforce the Clean Air and Clean Water Acts. It did not have the ability to levy fines or to prosecute anyone when it was first established, and that didn't come around until, let's say, the late 70s, 76 or 77, when the federal government strengthened the EPA's ability to go after companies, make people pay into Superfund for some of the contamination that's found around the country. In 2007, interestingly, the Supreme Court ruled that the EPA has the authority, although it doesn't have a mandate to do this, which is to regulate CO2 in the atmosphere, at least the output of CO2. The U.S. is not part of any cap and trade system with regard to CO2, and so it has the EPA has not put a cap on CO2 emissions. You can imagine why. Capping CO2 emissions now makes business more expensive in the U.S., and the argument will be that, well, we will not be competitive elsewhere in the world. Well, the cap and trade system already exists in Europe under the Kyoto Protocol, and has it's been relatively successfully used, although it has some problems as well. The environmental movement in general, I think, was kind of kicked off by a couple of things. There were, of course, filthy rivers, okay, that people couldn't drink from. There was one river that actually caught on fire somewhere in Ohio. And then there was a book that was put out, and this book was called Silent Spring. It was by Rachel Carson, and it was about putting toxins into the environment, essentially. And the Silent Spring represents a spring in which life, which kind of begins new after winter, is not there because we put the kind of toxins into the environment, things like DDT or dioxin, which you probably have come across in your Superfund projects. Challenges for the EPA on the left-hand side here. Okay, how do we set detection limits and MCLs? I had you look up MCLs for drinking water, and this stuff is in your book. 500 parts per billion, okay, parts per billion for lead, 150 parts per billion for mercury. There are a lot of chemicals out there that probably should be regulated and that under certain circumstances will be toxic. It's very difficult to figure out what the maximum level should be and to do it for every single chemical. Okay? So this is one of the issues with sort of establishing the limits for clean water, right? One of the other things to think about is that there is no zero pollution possibility here, at least right now, in part because we don't have equipment that can test for the traces to most minute amounts of pollution. Every piece of equipment that does an analysis of lead or mercury has, something which will report essentially zero, okay, for the machine, which is or below detection limit, BDL, will show up on the analysis. Below detection limit means that we know how much we can find, but we can't actually get it down to zero. So these are issues that the EPA sort of has to deal with and face. On the international side of things, we've seen that many policies have been ratified since the 60s, and I talk a little bit about some of these. The Kyoto Protocol, the Earth Summit, these really started and picked up in the 90s, and they were related to CO2 emissions. The Montreal Protocol, which came about due to which limits CFCs and hydrochlorofluorocarbons as well, which get pushed out into the atmosphere. And that was about closing down or stopping the depletion of ozone in the northern and southern poles. The Kyoto Protocol was an attempt to reduce the production of CO2 following what is a kind of precautionary principle. Okay? And that precautionary principle basically says, well, instead of waiting for bad negative things to happen that are measurable, we're going to anticipate this and try to stop them. So the idea would be that instead of waiting for climate change to reach its sort of zenith of disaster and then start blaming everyone and taking people to court, we'll work on reducing our CO2 emissions. One of the problems with these types of provisions of these international treaties is there's very few or little enforcement provision. Okay? If you're going to do fair trade, there is the World Bank, right? There's some kind of mechanism to levy fines against countries who are, basically not participating correct or well. But with regard to the UN, which governs some of these policies, the Kyoto Protocol was never ratified by the US, and there's no enforcement provision. So basically the European countries are participating in this. The US has chosen not to, partly because it never got through Congress. Okay, so it still sits in Congress. And again, here's the Paris Climate Agreement, right? Which was about transparency, accountability, and setting more ambitious targets. So here's the targets for 5.2% below 1990 levels by 2008, 2012, which weren't really reached. The Paris climate wants to limit temperature rise by lowering CO2 and other greenhouse gas emissions. And these kinds of policies come with a common but different responsibility of states idea behind them. The Kyoto Protocol has three ways of dealing with lowering emissions. One is emissions trading. So the Europeans have a cap and trade system, a CO2 cap and trade system, which I kind of talk about a little bit over here. And that has helped to level off or to reduce some of the emissions coming from the European Union. Probably the most successful treaty regarding international law and policy would have been the Montreal Protocol and its subsequent updates, which really, if you take a look at CFCs in this chart here after the Montreal Protocol, really were going up in the 80s and early 90s, okay, and then they level off in the early to mid 90s after that, and we see them kind of flatten, in some cases decline. What you do see is that not everything was fully regulated by the Montreal Protocol, and we get HCFCs actually still increasing, and so we're still working to regulate those today. With regard to the Kyoto Protocol, there are three ways in which the Kyoto Protocol worked to lower emissions. One was emissions trading, which I talked about, the cap and trade system. Clean development mechanisms, which would have been essentially going to developing countries and providing them with technology or funding that they did not have to help them develop cleaner coal fire plants, or maybe develop refineries for oil and gas, or maybe develop ways of implementing renewable resources. And then we also have joint implementation between countries. So there are three mechanisms to kind of essentially spread the amount of CO2 emissions across different countries and to help other countries limit the amount of CO2 that they generate. You know, right now, if we take a look at the generators, right, developing countries that are generating a lot, okay, this is showing us the map of the world in proportion to the CO2 emissions, or the CO2 generators. So Canada, tiny up here, right? It's a very small generator. US, one of the biggest, or the biggest actually, is bigger than all of Europe by 3% or so, just under 3%. Okay? And then we see developing countries, Africa, not a country, developing areas, I should say, continent, and South America. They have relatively small emissions, but we see China and India really growing and getting big in terms of, you know, how much stuff they're going to put out into the atmosphere. All right, so that kind of wraps up a summary of some of the issues associated with waste, pollution, hazardous waste, as well as CO2 emissions and the international regulations associated with CO2 emissions. It makes a lot of sense to think about the fact that, you know, because many of these agreements you can just back out of, like the Paris Accord, which was very recent in the last 2 years or so, the Kyoto Protocol, which we actually never ratified, it makes sense that, you know, the climate issue still stands right in front of us, especially because one of the biggest emitters, which is the U.S., isn't really participating in this. And you will find that the strong argument against participation is economic, the negative economic impact that it might happen or might have on the U.S. That's one of the primary ones.